Hi everyone, let's talk about the homework for meeting number 7. The homework was to brainstorm some ideas to upgrade the classic Caesar cipher process to increase the safety of the encryption. You can use text, audio recording, or even videos to share your idea. It can be put into a Python file, PowerPoint file, animation file, or video file, but make sure to put the right formatting for the file name. And then email the file or download link to me before 7 a.m. on Monday, which you guys did. It's okay if your idea is not fully thought out yet, and they will be marked in this video. So that was the homework. Let's look at the first homework that I got, which is Richard Huang's. So he gave us two ways to encrypt. The first way is to convert the letters to numbers. If they are two-digit numbers, then we subtract each number by 10 and add it. Subtract each number by 40 and add it by 10. And this method was really successful because Richard also gave me a Python code that worked perfectly for this method. But he also gave us a second one, which is to convert those letters to numbers that are two digits, from 10 to 61. Swap places with each second number, and then swap places again with each third number. Repeat this process until you swap with each sixth number. So this method seems to be more complicated, and I assume that for swap places with each second number it makes sense because you're swapping every two numbers. But for each third number, do you mean like swapping the first number with the third number and the fourth number with the sixth number and so on? So that's like one place where I was a little confused, but I think your second idea is pretty good too. So let's look at the code for your first idea. So you have two different Python files, one for encrypting and one for decrypting. For the encrypting one, you have this function. So you take in the character and n. After you have the character, you find the ASCII code of it. If the code is greater than or equal to 40, then you subtract 40 from the code. So you were very smart to pick 40 because when you pick 40, you include all of the characters after 40. So like all of the lowercase letters, uppercase letters, and the numbers. So like for example, if you pick 50, then it would not be a good choice because you would not be able to encrypt 0 and 1. So choosing to make the 40 as your number is a very good choice. And then after that, after we have subtracted 40 from the number, we add n, which is like a random number that we can choose. But in your example, you use 10, which is also a good choice because n can't be too big. N has to be less than or equal to 17. Why is that? Because, for example, when we have like this really big ASCII code, like for lowercase letter z, the ASCII code is 122. If we have n equals 18, then we would encrypt it like first subtract 40, which becomes 82, and then add 18, which becomes 100. And then that wouldn't be good because 100 is a 3-digit number, whereas all of the other encrypted characters turn into 2-digit numbers. So if it's like a 3-digit number, then when we're decrypting it, it shifts all of the bookmarks and stuff, and then it won't work well. So n has to be less than or equal to 17. And I like how you made this n, because if we have this n, then it allows us to conveniently and periodically change the offset. So like we can change it. Instead of always doing minus 40 and plus 10, we can change it to like minus 40 and plus 11 to make it harder to decrypt. So the n is very good too. So for the encryption, so far we have minus 40 and plus 10 to the original ASCII code. And then we turn that encrypted ASCII code into a string, and then give that string to a new number. So new number is a string of a number. And then we return new number. So if it's like one of the characters after 40, after the ASCII code of 40, then it would get encrypted like that. But if it's like before 40, like most of the control codes and some of the punctuation, then it just gets basically thrown away because it gets turned into an empty string. So if we put control codes or these types of punctuation in the plain text, then they won't appear in the ciphertext. But that's not a big deal, and it's a good thing that we threw away the control codes. So that's your function for encrypting the characters. Now let's use it. So you open plaintext.txt in read mode, which is this plain text, and then we encrypt it here. So we have an empty string first, and then we encrypt each character where n equals 0, and then add it to new string every single time. After we finish this, we will have a new string which is full of encrypted characters that are a lot of 2-digit numbers like squished together, and then we close the file. And then so we have this new string, we're going to put it into ciphertext.txt. So we open ciphertext.txt in write mode, and then write new string into it, and then close the file, and print ciphertext file was created. So after we run this encrypt, it will have a ciphertext in the ciphertext.txt. So now when we look, it has this very big string of numbers, which is the ciphertext. So far we have encrypted the plaintext successfully. Now let's decrypt it. So for decryption, you have this function as well, which is basically reversing the effects of your encryption function. So first, because in the encryption we minused 40 and added n. So in the decryption we would minus 10 add 40. So the offset here is the same as n, which is 10 in this case. So we run it with 10. So after we minus 10 and add 40, it becomes the ASCII code of the original character. So we just need to turn that ASCII code back into the character. So, and then we print number, which is the ASCII code, and then the character, which is the character in the plain text. And then we return character because that's what we want. We want the character in the plain text, so we can make the plain text. And then we open ciphertext. Okay, so this is the function, and then now we're going to use the function. We open ciphertext.txt, which is the string of encrypted numbers, in read mode, and then read it. And then when we're decrypting, we have this empty string first, and then we have an index, which is basically a bookmark, so that we know when we need to look at the next numbers. So first it starts at 0, so we start at the beginning of the string, like there. And then we have this loop, while index is less than the length of ctxt, which is the string of the ciphertext. So while the bookmark isn't longer than the string in the ciphertext, we will continue decrypting it. So when we decrypt it, we first slice the string using the bookmark, and then the bookmark plus 2. So in the first loop, it will be from 0 to 2, because we know that the ciphertext, every 2 digits is 1 character, so we do plus 2. That's why we wanted all of the encrypted numbers to be 2 digits, so then it would be easier here. So if it's 3 digits and we plus 2, then it would get messed up. But now it's all 2 digits, so this works well. So we slice it. So in the first loop, we would get 5 and 0. And then after we get 5, 0, we turn it into an integer because it was originally a string. So after we turn it into an integer, we could run it into the function. And then we add 2 to the bookmark. So like, first it's 0, now it's 2. So in the next loop, it will look at next 2 numbers. And then after we change the index, we decrypt the 2 numbers that we have, which is 5, 0. So we run it into the function, and then it gets decrypted, and then we put that original plaintext into the new string. So every time the loop runs, it will get added new characters, which will make up the original plaintext. After we have looked through all of the numbers in the ciphertext, then this loop stops, and then we close the file. So now we have the plaintext, and then we open decrypt.txt in write mode because we're writing in it, and then we put new string, which is our plaintext, into it and close the file. Lastly, we print decrypt file was created. So after we run this, we will have this decrypt.txt with the plaintext in it. So these are all of the characters and their code points. So let's look at decrypt.txt. We can tell that it has like this message that is very readable. And if we compare it to the original plaintext, we can tell that the only thing that has changed is that the spaces were taken away. Okay, the quotation marks were taken away too, but we can see that the period is still here, and also the numbers were preserved as well. So all in all, this code was really successful because after we encrypted and decrypted it, the message is still completely readable and no meaning has been lost. And this code is also very safe. And the code was perfect because I didn't find any errors in it. So good job, Richard. Now let's look at Adrian's homework. So Adrian told me in his email that he wasn't able to encrypt or decrypt the document at all because the Python file couldn't find the text document. So that is because your text document was not like in the same folder as your Python file. Your text document was in downloads, but your Python document was under documents and then RC2203. So in order for our code to work, the text file needs to be in the same folder as the Python file. So in the last video that I made for marking the homework, I explained 3 different ways for locating a text file. There is relative location, absolute path, and a way to find the document on the cloud. But in our Python code, we're using the relative path, which is just putting the text file under the same folder as the Python file. So once you do that, it should work. Now let's look at your code. So I changed 3 or 4 places in it. First, the text document that we're going to use for the ciphertext is this one. If you want to do some testing with your own document on your own, that's fine too. But for our homework, it was supposed to be this text file. So this is the ciphertext that we wanted to decrypt. And then here there was a typo because you need to add a T after the char convert. And here there was another typo, so you spelled input wrong. And here I turned this block into a comment because this wasn't really needed in the code. So now let's run the code with the new changes. Here are all of the possibilities when the offsets are different. So the good offset is the last one because it's the one that is readable. So we do 25, and then it creates this file called plaintext1.txt with the plaintext in it. So now it was successfully decrypted and your code works now. Next, let's look at Brooks. So Brooks gave me a video explaining his ideas.
I think how I can make the Caesar cipher more safer, or like how I can make it safer, is just combining all the words together. So like I and I think like because like they're easy to decrypt, so you just put them like everything together and like ignore the punctuations. then it'll be harder to decrypt. I think how I can make the
So your idea was really good, and I also put that idea in my video for like the class. So it's good that you can learn and apply the knowledge and can share your own ideas. Next time, try to think of some original ideas that I didn't talk about. But yeah, that idea was really good. Now let's look at Dylan's. For your meeting number 6 homework, there wasn't any mistakes in it, and you found the place that needed to be changed, which was this line. So, very good. And you also gave me the result for after you ran it. You didn't need to, but yeah, this is the right one. So I'm gonna run it too. And it decrypted the ciphertext and the plaintext was generated. So everything works well. Next, let's look at Ellie's. For your code, there was a lot of mistakes in it, so I just turned the parts that had a lot of mistakes into comments. And then I put the original version into it without the mistakes. So because there are a lot of mistakes, I'm going to show you how to proofread. You need to open Notepad with the original code in it, so there are two windows in the same screen, and then you can compare it with each other. For example, like say this is the code that is like the original code that I sent out. You can compare it side to side. So for example, we can see that on the second line, you need to do n equals n%26 instead of, so you're missing an n here. In the third line, it should be a capital letter Z and capital letter A instead of a lowercase letter z. And like for here, it should be just CHR instead of CHAR. So like that, you can compare your code with my code. Because I said that there was only one place that you needed to change in my code, which was this part. You only needed to change the file name. So like for the other stuff, you can basically copy paste my code or edit directly on my code. So you don't need to have so many mistakes in it. And then the other part that I turned into a comment was here. And then I put this part, which is the correct one. But these two ones were good and they didn't have any mistakes. So I changed the parts that needed to be changed, and now your code works. So it generates all of these possibilities, and we pick the one that is readable, which is 25. And then we tell it it's 25, and then it gives us the plaintext, which successfully decrypts the ciphertext. So just remember to proofread. Next, for your code for number 7, the same thing. There was a lot of like syntax errors in it, and it wasn't understandable. So I didn't try to mark it because there are too many mistakes. So you should proofread like in your meeting number 6 homework, because you're only in grade 4, so it might be a little bit hard or challenging. So you can start by copying, finding mistakes, and proofreading if the original code is too challenging. For this meeting number 7 homework, use words to show your ideas of how to upgrade the original Caesar cipher. Like, think of an idea of how to encrypt it to make it harder to crack, and then type it into a text document and then share it to me. And I hope to receive your number 7 homework again. I'll mark it with the number 8 homework. If you want to improve Python, there's a really good Python tutorial on YouTube. You search Zongtian and then Python. The videos are really easy to understand with a lot of details because I also learned Python with him. But the teacher talks in Mandarin, so you need to know Mandarin to understand. If you don't know Mandarin, there's also a lot of tutorials in English. Just search like Python tutorials and there will be a lot of good ones too. because we only used 7 classes to explain Python, so we can't learn it with as much detail as the videos on YouTube. So like in this class, I also taught some Python, but it's not as detailed as the ones on YouTube. So if you have any questions, you can ask me, but like if you want to learn more, you can also search it on YouTube and watch some videos. And like here's the Chinese version if you need it. It's the same as this part. So just remember to proofread and watch some videos on YouTube if you have the time. Now let's look at Gary's. His idea is swapping the end words with each other. Like for example, the word words can be turned into swords. So he swapped W with S. And I think this is a good idea, but you can go further by making the swap more complicated. Like you can also swap D with O, and that will make it more complicated. Also, there is like one thing that is not good about this like swapping method, because when there are one letter words like a or I, it doesn't get changed, so that might give it away. Next, let's look at Grace's. So you gave me 3 different ideas. The first one is to move odd position by 2 and even by 3. So the first letter moves 2, second letter moves 3, third letter moves 2, fourth letter moves 3, etc. This one is a good idea, but it can be cracked easily because it's like a simple pattern. The second one is use position as the offset value. For example, the first letter moves 1, second letter moves 2, third letter moves 3, etc. This is a really good idea, and it can be turned into Python code easily, so it is easy to like do in real life. So I like the second one. The third one is use a rule to completely scramble the letters. This one is the safest, but it might be the hardest to do on Python, and we need to think of a rule as well, because like scrambling the letters has a lot of different ways, but it's a good idea. Next, let's look at Henry's. So, there wasn't any mistakes in the encryption or the decryption code, but for the homework you needed to like give me your ideas for how to make the Caesar cipher safer. Like think of a way to encrypt it. So like this is the same as meeting number 6. So there was no mistakes in the code, but it wasn't what I was asking for. Jesse's. So you gave me 2 ideas. So the first idea is like making an offset by determining the placement of the letter. So your example said you can shift the first character by 25, the second by 14, the third by 17, the fourth by 10, and then repeat the pattern. The fifth character gets shifted by 25, the sixth by 14, and so on. So this is a good idea. To go further, we can make the offset and the letter placement have a relationship, like a function where y equals fx. Like this, it would be easy for the code, and it would be easy to change too. So like we could change the 25, 14, 17, and 10 into different numbers. Your second idea is to turn the words into 3-letter words by slicing them, and then changing swapping the letters. So for each 3-letter word, there are 6 ways to do it. We can let the code decide how to mix them up, and this is a good idea. This is a good idea too, because it's easy to do in the code. Next is Joey's. So for meeting number 7, you put basically the same thing as you did in the homework for number 6. For number 7, you needed to think of your own ideas to make the Caesar cipher harder to crack. So, like your code has only one mistake. Other than that, it's good, but it's not really what I was looking for. So you should like come up with a few of your own ideas on how to encrypt using the Caesar cipher, but tweaking it a little bit to make it harder to crack. So the one mistake in your code was like you mod it by 25 instead of 26. So like the reason why this doesn't work is because there are 26 letters in the alphabet. So if you mod it by 25, like the plain text doesn't is disappears. It doesn't ever get shown. So like if we try doing yours and then run it, we know that the right plaintext is like possibly the most important code breaking event and then something. But that starts with a P, and we can tell that like all of the possibilities are like following the alphabet. When the offset is 1, it starts with an R. Offset is 2, starts with an S. So it's like R S T G V W X Y Z. When offset is 10, the first letter is the A, and then A B C D E F G H I J K L M N O. But there's no P between O and Q. And P is the one that we want because it starts with the word possibly. So when we like mod it by 25, the right one gets skipped over. So we don't want that, and then it wouldn't work. So like we need to change it to mod by 26. So now the P gets found. So the good offset is 25. This 25 is not the same as this 25. And then now it works with the right plain text. So I think you did like the same thing as meeting 6. Maybe you sent it wrong, but like for meeting 7, you need to think of your own ideas to upgrade the Caesar cipher, like tweak it and then make it harder to encrypt or decrypt. Next, let's look at Mitchell's. So you gave me 3 ideas. The first one is to replace every letter with a different symbol. For example, banana, the B turns into a period, A turns into a slash, N turns into a single quotation mark, and then that's basically the same as Caesar cipher. Caesar cipher is replacing every letter with a different letter. So the characters all follow the same pattern, and it can be cracked by examining the frequency chart of English characters. Because in English, when we like do a normal message with normal grammar and stuff, there are certain letters that appear more frequently. So if we use a English character frequency chart, it's easy to crack like that. So this is basically the same as Caesar cipher. And then that's why I wanted you guys to try to make it more secure. So the first one isn't super secure. The second one is put the first letter in every word together, the second letter in every word together, and so on. For example, bananas are tasty, and then we put BAT for the first letter of each word, and then the second letter of each word, so ARA. The third letter of each word, so NES, and then the fourth letter, and so on. So for here, I think if we do this into a code, the computer would not do it like this. It would do like for AT, it would do A space T because for the computer, the second word doesn't end here. It has like spaces after it. So like here, it would do try to find the fourth letter of each word. So A and then space because it doesn't detect any letters here, so it's gonna put a space and then T. So like that, it would have a lot of redundant spaces. So, but it works, and I think this is a good idea. The third idea is to put a random letter between every letter of every word. For example, like monkeys are hairy. You added an A between M and O, a D between O and S, F between N and K, and other random letters between every letter of the original word. And I really like this third idea because it's not a regular encryption method, so it's really original. There is a redundancy of 50% because like half of the characters in the ciphertext are not useful at all. But this is a good way to distract like the person that's trying to crack the code. So this is a really good idea. Next is Dylan's fifth homework. So there wasn't any mistakes in it. I just wanted to tell you that to make sure the paragraph.txt needs to be under the same file as the Python file so that it can find the paragraph.txt. Other than that, the code is really good. Okay, let's run your code. So this was your original message, and then it gets encrypted, and the encryption is successful because if we encrypt something by 2601, it's the same as encrypting it by 1, right? So like A turns into B turns into C. So the code was successful. Now the sixth homework. For this one, there was also no mistakes at all, so good job. So when we run it, the good offset is 25, and the ciphertext gets decrypted. So the sixth homework is really good too. And then that's it for the homework. I really like your guys' ideas for the different ways that we can make Caesar cipher more secure. And you guys were really creative. Thank you for watching.